Welcome to the Grass Valley booth at NAB 2018. We're going to be talking with Chuck Meyer, CTO for production at Grass Valley. So Chief Technology Officer for production for a company that makes a lot of production equipment. What does that mean?
Perfect question, right? Everybody wonders, what's that production mean? So, we have a rich heritage of live production equipment, cameras, production switchers, go to Air Live, any sporting event right now, quality on time. So my job is to make that transparent to our users while we adopt the new technology, things like IP, and look to a future roadmap so that as we build our products, we can do it efficiently and productively and keep you on the leading edge of technology without destroying your workflow and actually enhancing your workflow. That's what I do.
So let's talk technology. Let's talk standards, and one particular standard, the standard of the day of the year, SMPTE 2110. What's the status of 2110?
Yeah, we've made a lot of great progress as an industry. Late last fall, SMPTE published. That means it's approved, documented, and out there in the world. We published 2110-10. It's your system functionality, how to use precision time protocol, the basics of IP transport. -20 is the video transport. We did -30, which is the audio transport, very similar to AES 67. And then in addition, we have -21, and this is the traffic profile for the audio, and that's a very important thing for the industry. Right now, we're very close to publishing something called -40. This is the traditional metadata, ancillary, hank and vank, and how do we put that into an RTP stream. And we're working on -31, which is tunneling AES 3. A lot of Dolby E and other types of compressed work is done. And we want to bring that transport, that audio type into the workflow so that everything can be coherent in this new modern RTP IP environment.
So when we're done with all these dashes to 2110, does that mean that all of the interoperability issues are now behind us?
Yes and no.
Right.
Yes, I know, exactly. Yes, I've got two pieces of equipment. I've got a camera and a production switcher. I'm going to get the bits between those two pieces of equipment. One of the amazing things about IP is how flexible it is. So to really say I have total interoperability, I need to be sure that the camera and the production switcher are speaking the same format. They better be 2K P60 HDR, for example, or 4K P60 HDR. And IP does this in a very unique way because once the data gets from A to B, then you can actually examine that data. And the camera can say, I'm sending you this, and the switcher can say, oh, I'm receiving this. And then we have the complete handshake, and then the pictures work. And this all happens like this. We've learned it as plug and play. And this is what gives us our interoperability all the way up through all the different formats, and it lets you focus on the formats you need for your customers, your use cases in your business.
So let's tunnel down a little bit more to what's called wide and narrow profiles. What are they, what are their differences, and what are their uses?
IP traffic is not like every bit on a wire perfectly in SDI. It's all digital, it's got a little bit of jitter, a little bit of wander. If you go to the source of a piece of equipment like the camera, if we control very carefully how it puts its packets on the wire, how it puts that data out there, even though it's a little looser than SDI, we control that, nice little narrow uniform groups of data, and we get exceptional signal performance, the lowest latency and the highest guaranteed throughput in that COTS IP router that you bought. One of the other things about that is a COTS IP router, it incorporates memory as a way to move the signals through and switch them forward them between sources and destinations. And that memory is important. If I throw too much data in there at once, I could overrun it, I could lose a packet. It's called oversubscription. So the narrow profile basically ensures that lowest latency and pretty much any switch out there, you don't have to worry about that. We still have software products. We have different types of signal processing things, and these are going to live in computers. They could be virtualized devices. They'll have a problem making that exact timing of N. That's called W. What we do in the standard is that wider gapping, that higher peaking, the equipment still complies with a looser level, we can use that, we can add up that equipment, and we can calculate if you need a little more memory in the switch. So as a system designer, your system integrator, they can help you say, I want this switch, but I'd like your extended memory option, and that's something that is available throughout the industry from numerous vendors. So it gives people a way to manage both workflows, one network, software appliances, real-time devices.
So what's next with IP with regard to SMPTEs and the standards bodies and working groups, and we're not obviously just going to stop at 2110.
No,
What's coming up? What are we working on?
So what's coming up is we're looking at things coming into production. There's still things like light codecs used for bandwidth savings. These can be used in real time. They're imperceptible, so we're doing some things to work on generically letting those exist in the 2110 environment. Probably one of the biggest items now is metadata. And if we look at something like Dolby PQ as an example, we have dynamic frame-by-frame metadata. It's important that we have that. Another application for metadata, we're showing it right here on our booth. We're showing you Moses. So motion tracking, we've got stars on the ceiling, we've got the focal length of the lens, we've got zenith, azimuth, or pan and tilt. All of that information, we'd like to store that metadata. Where's the camera? What are all those dimensions? It's going to let us do automated 3D rendering and all kinds of fun things. That metadata is just as important. It needs to come along in real time, and SMPTE is now starting to turn its focus onto those types of things. I hate to use the cliche, but that's how we build the Internet of Things for broadcast production.
Excellent. So if there's one takeaway you want for people who've come to the Grass Valley booth during NAB, what would that takeaway be?
You know, my takeaway is, remember how SDI was like a cable and you didn't really think about it? Well, IP is that cable on steroids. It's more flexible. You don't really need to think about it. And Grass Valley wants you now to get back to your business, creating great pictures. And we have a wonderful set of tools here that lay on top of your IP backbone in your plant to let you create compelling pictures.
Thanks, Chuck, very much. And thanks for joining us from the Grass Valley booth at NAB 2018, Las Vegas.